Your notes out. We'll do a little. You just gotta watch out. But everything in this unit is connected. Okay. You can always use the skill you're learning and apply it to something else that we're doing down the road. Page 6. I did this in yesterday's video. I worked through this. Okay. Also down here when it comes to the fuel economy. So we had to figure out how many liters would it take to travel 840 miles. We figured out that it would take this many liters. I'm not gonna go over this right now in detail, okay? So you just go and it's a shorter video. It's up. So I forgot to answer this one. You can tell that I'm a little forgetful these days. Maybe I should be worried about that. But anyways, how many miles could you travel on 45 liters? How would you answer that? This is still part of the other question. So I want you to know that when you solved the 118.96 liters, right? You determined that you could travel 840 miles with that many liters. This is actually from I, right? From I, right? I solved this portion, but I know that these are true. They go together. Mr. Dixon, would it matter if I put miles on top, liters at the bottom? It wouldn't matter. Okay, that's the beauty of proportions. So I'm just going to say that if I had 45 liters in the tank, how many miles would I be able to travel there? And just make sure when it's an equal sign that the units line up. Okay, they have to line up. And I'm just going to quickly answer this because I want to make sure you have examples when you go back and you check. But I cannot do everything that can possibly come your way. That's where doing your own work at home is important. And that's why I do put the detailed answer keys, not just the answers. And if you're still having questions, please see me the next day or message me. Okay, I'll try to clarify that. Now, these two questions are what we call design and measurement types of questions, like renovations, painting, stuff like that. And before I jump into this, I want you to go to page 8, and I'll give you some notes before. There should be two blank pages, right? Page 8 has an extras section to it. I'm going to use that formulas. I'm going to just call this formulas, right? As you can tell, the surface area of a rectangle, I think you would all agree that it would be 2 times, sorry guys, I need to make sure, rectangular prism. A prism is just a 3D, right? It's a box that is rectangular with a base that has a rectangle. And let's make a little box here real quick. As you can tell, my artistic skills aren't the greatest. That'd be your classic rectangular prism. So there'd be length, width, and height. And I'm sure you remember, or if not, you will at least remember once you see this, right? But 2 times length times width would be areas of the bottom and the top, plus 2 times length times height would be the front and the back, 2 times width times height would be the sides. Okay, so this is top and bottom. This is length and height, be front and back. And this is the sides, left and right, basically, right? But anyways, we're gonna go word problems, right? Top and bottom would be ceiling and floor, correct? Ceiling and floor. And this I just call all of these four, like, because there's 2 sides and another 2 sides, correct? So all 4 sides would be the walls. Okay, so if we take it one step further, the length and the width represent the top and bottom, and the sides would be the walls. Therefore, surface area of walls only would be 2 times length times height plus 2 times width times height. So let's say you only want to paint the walls of this room, right? You would only, that formula that I gave you up top reduces to just length and height, width and height. And I will highlight the height, because when you multiply one of the dimensions by the height, right, you should remember, oh, the height represents the walls, right? There's probably walls involved there. Surface area of walls and ceiling, because you'll find out that there's a lot of painting going on with these types of questions, and we don't paint the floor most of the time, right? So if it's walls and ceiling, you end up with length times width, just like that, plus 2 times length times height plus 2 times width times height. What's the only difference between this one right here and the very top? You notice that this 2 is not there. There's a 1 there, right? Because we're only now painting the ceiling, okay? So these formulas are very important. And I'll give you more tomorrow, but I'm going to jump into the example before we go. That's why the extras, these pages will be used for any formulas that follow. So just make sure, you know, some students only need this formula and they understand what needs to happen. They don't need this one and this one because they know how this works, right? So just keep in mind that that's the case. So let's go back to page 7. Okay. One can of paint covers 200 square feet, right, and costs $29.99. Okay. Calculate the cost of painting a room that has a surface area of 500 square feet. For proper coverage, 2 coats are required. No partial cans can be purchased. Circle that. That's very important for us to design a measurement. You cannot buy partial quantities. Okay. I will give you some steps here. Determine total surface area to be painted. Then determine cans required, then calculate the cost. Do not jump the number of cans required, okay? And I will say this, it could be cans, boxes, you name it, but figure out how many you need, okay? I will say round to whole number. Okay. So step number 1, right? Surface area. We need 2 coats of, we're painting a room that is 500 square feet, right? So 2 coats, you need to paint this room twice. So it's essentially, right, the surface area to be painted is essentially 1,000 square feet. Then I will figure out, they're giving me, watch this, a can covers this much and it costs that much. And so sometimes students are confused what needs to happen first. Figure out how many cans first. I know you've done this in IPR, right? So 1 can covers 200 square feet. Therefore, how many cans, right, will I need to cover 1,000 square feet? So you cross multiply and you divide, okay? So x would be 1,000 times 1 divided by 200. There's some of you would just immediately divide. You would go 1,000 divided by 200. That's fine with me, okay? Just have that step included there because it's 1,000 divided by 200, right? And that would be, can I make a change just to prepare you for this? Follow me, okay? It's a small change. We're gonna change this to 180. 1 can covers 180 square feet. And let's go down here to our setup. We need to change the 200 to 180. It's a pretty easy change, right? So you just got to make sure all the 200s are turned to 180. Otherwise, it's going to be a round number and you will miss the point there. So it's really 1,000 divided by 180, which gives you 5.55 repeated, right? 5.55, and that keeps going, which is approximately, in this case, I need to buy, as soon as it's point anything, 0.01 even, you need to buy that extra can to make sure you have enough. So you need 6 cans to paint this room. And then you go to the cost, okay? You go 6 cans times $29.99. It's $179.94. This is before taxes. Before tax. I haven't added taxes. I don't know if you learned this, but if you want to quickly add 12% tax to anything, just multiply it by 1.12. Did you know that trick? I thought so. You're a smart bunch, right? So that's 201.53 after tax. I think we should be able to do that, right? That shouldn't be a stretch to figure that out. I think I'm going to stop there because I want to make sure you're set up for what's next. I would like you to, you can see the homework, it's at the bottom here. page 1 or 2 in the workbook. But I want to hone in on what you don't do the textbook. Obviously, you don't have a textbook yet, so you can't. But page 1 or 2, it's in the workbook like this. Maybe don't worry so much about the conversions. Worry a little bit more about the thinking questions, right? Like the word problems. It says more than one way to find the answer because it's true. Right? And then page 2, there's a bunch of word problems there. Do not worry about the scale diagram just yet. If you see scale diagram, just say like, you know what, I'm going to wait because Mr. Durson will get to it. Right? So you pick and choose. I'll post the answer key to both of them. And I won't AC you tomorrow yet, most likely not. If so, then it's going to be just basic convergence again. But I think I will just continue with some more examples for you, okay? Thank you, guys.